Hello, my name is Caitlin, and I will be teaching you 5 concepts of food science. First, I would like to start with sugar. Sugars are one of the most essential substances used in everyday food, but let's break it down to the simple sugars, monosaccharides. Monosaccharides are simple sugars that are building blocks of larger carbohydrates. For example, glucose, fructose, and galactose are all monosaccharides. Monosaccharides are known to be made with one sugar molecule, hence the mono prefix in its name meaning one. With these monosaccharides, we can create more complex sugars like maltose, sucrose, and lactose, which would be considered as disaccharides. Disaccharides contain two sugar molecules, hence its prefix di, meaning two. Now, I would like to go a little deeper into disaccharides and how they are digested. Because disaccharides are more complex, they need a helper known to be enzymes in the digestive system to help break down these molecules. And usually enzymes are containing the suffix ase, which can be a helpful tip that can differentiate it from other molecules. For example, the enzyme for maltose is maltase, the enzyme for sucrose is sucrase, and for lactose, it's lactase. For sugars, the small intestine is the singular location of digestion and absorption. Now, an interesting thing to look at as well is lactose intolerance. What is that? Well, the reason why lactose intolerance occurs is because an individual has a low number of lactase, which is the enzyme that breaks down lactose. So because they have low lactase, they're unable to digest lactose, which can cause stomach aches, gas buildups, and bloating. Now, I would like to move on to fats versus oils. Now, both are lipids that contain a chain of carbon, hydrogen, and oxygen, but the thing that makes them different are the chains that connect these carbon molecules. Oils are considered as unsaturated fats that are liquid at room temperature due to the double bonds between carbon molecules, while fats are considered saturated fats that are solid at room temperature due to the single bond between carbon molecules. Here's an image to help visualize that single and double bond. And it's so interesting how these bonds can drastically make an oil look different from a fat, as well as how they could affect baked goods like cookies and cakes. Here's where we would introduce that science in food science more clearly. You may not know it, but the browning that occurs when cooking food is due to a cascade of reactions between protein and carbohydrates, which is often referred to as the Maillard reaction. Let's watch a short clip of a video to get a general summary of the reaction and learn more about the true nature of food science.
Toast, the Maillard reaction has transformed your raw ingredients into something that tastes crazy good. Sometimes called the browning reaction, Maillard actually involves a cascade of many chemical reactions, all happening while your food is cooking. These reactions involve the sugars in foods rich in carbohydrates, think bread and potatoes, and amino acids, the building blocks of proteins that make up dairy, meat, and nuts. More importantly to cooks and people who like deliciousness, it produces hundreds of compounds, some of which contribute amazing smells and flavors to cooked food. You've got your alkylpyrazines, which contribute the cocoa flavor or nutty roasted flavor in coffee, or the caramel-like pheromones found in bread and toast, or the meaty thiophene that pop up in, meat as well as garlic. The color of beer, the smell of popcorn, and even cookies all wouldn't be the same without the Maillard reaction. Since French
Lastly, I would like to talk about shelf life. Shelf life is defined as the amount of time a food product can be safely stored before deteriorating. So if a food is left out for a long time, spoilage can occur, and this is due to microbial activity in the food. Microbial activity is the activity that is done by the presence of microorganisms like bacteria and fungus. Now, the reason for different shelf life periods and expiration dates can be explained through unique water activity and moisture levels in foods. Water activity is basically measuring the amount of moisture available in a food. And the higher water activity of a food means that the more moisture is in the food and more likely that microorganisms will appear faster, compared to drier foods that have lower water activity. Moisture levels are essentially the same thing. The higher the moisture level, the more likely that microbial activity will occur sooner. Thank you so much for listening, and I hope you have a great day.